Hi guys, for 2.6 we're going to be talking about absolute value inequalities. So hopefully you'll remember a little bit about the absolute value equations, which we're going to go through here. Recall that when you are talking about absolute value equations, what you're remembering is that the absolute value, which is symbolized by these two vertical bars, is always positive, because what it really is talking about the distance something is from zero, and distance is always considered positive. So we talked about with absolute value equations the idea that when you have an absolute value equation, it should always be equal to a positive. And the steps to solving absolute value equations are, first, you need to make sure that you isolate the absolute value part. The next thing you're supposed to do is to ask yourself if the absolute value part is equal to a positive, because if it is, then what you're supposed to do is set up the two cases, and if it's not, then it's considered no solution, because you cannot have the absolute value of anything be equal to a negative. Then after that, after you set up the two cases, you, which is step 3, solve each part. So as a quick review from absolute value, we can look at these two questions that we have here. And if you see, for example, this question, the first one, you're going to see absolute value of 3z minus 3 is equal to 9. The absolute value part is already isolated. As you could see, there's nothing being done to the absolute value. We notice that it's equal to a positive, so then we move straight to set up the two cases. Case 1 is that the inside is equal to the positive. Case 2 is that the inside is equal to the negative. And remember, the whole reason we're doing this, setting it up to the positive or negative, is because when you're in here, and this meaning 3z minus 3 in this example, this whole value could equal 9, so that when you take the absolute value, you get positive 9. Or it could equal negative 9, so that the absolute value of it will also give you 9. So then you continue solving both different parts by regular equations. Add 3. You get 3z is equal to 12. Then you divide by 3. And this one, you get that z is equal to 4. With the one on the right-hand side, you add 3 again. But this time, negative 9 plus 3 gives you negative 6. Then you divide by 3. And you get that z is equal to negative 2. So the answers to this would be the value of x such that, or z in this case, sorry, the value of z such that z is equal to 4 and z is equal to negative 2. Or you could just leave it like that. With this one, just as a reminder, isolate the absolute value. It's equal to a negative, so this is called no solution. So, keeping all of these little things in mind, what we're going to do now is discuss the idea of absolute value inequalities. Inequalities that involve absolute value are similar to equations that involve absolute value. It will look somewhat like this. Instead of it being an equal sign, you'll have a symbol. And just what it's asking is, it's basically saying to you, what numbers have a distance away from 0 that is greater than or equal to 3. If we wanted to picture this, we could ask ourselves, okay, let's see. In order to be 3 away from 0, you are either going to be equal to 3 or you're going to be equal to negative 3. So the numbers that have a distance from 0 of 3 are either 3 or negative 3. Or, in this case, they're asking greater than or equal to. So we don't want to know just 3, because it's or equal to, but we also want to know everything that is greater than 3 away. So because it's equal to as well, it says or equal to, we know that 3 and -3 are equal to 3 units away from 0. But also, as you move further away outward, all of these numbers that we're looking at here are more than 3 units away from 0. So, looking at that as an inequality and as the idea of solving an inequality that involves absolute value, you're going to do the same exact things that you did with an equation, or not exactly the same, but similar. They're still going to be the same steps. Step 1, so this is for solving absolute value inequalities. Step 1 is still going to be to isolate the absolute value part. Step 2 is going to be to ask yourself, thinking of, again, the fact that it's got to be positive, is it greater, less than, greater, equal, less than, equal to a positive? If yes, then you set up the two cases. And we're going to talk about the difference between the two cases with inequalities versus equations. If no, then there's actually two possibilities. It's either going to be no solution or, as you will see, all reals. And we're going to talk about what it is from that case. So let's talk about the ones that we have here. Here we have the inequality. We notice that it's a positive, it's isolated, it's positive. So now we set the two cases. The two cases that you're going to set up are going to be the following. And I'm going to use symbols to represent. If the absolute value is less than or equal to a value, then this is what we call a less than. It's an and inequality. So this will be, think of it this way, less than, and the two inequalities would be A is less than B and A is greater than. Look at the difference now. We switched not only the sign, not only the fact that it's equal to a negative, but now it's a different inequality symbol. And it's greater than the negative. Remember, in this case, what we're doing is here it's equal to a positive. So then we set up the two cases. Don't get confused when you set this negative up and think that it's no solution. This has been set up because of the fact that the original was positive. And it's an and inequality, and you set up the two inequalities. If it was greater than, this is the way that you would do it. If it's the absolute value of something greater than or equal to, it doesn't matter whether there's an equal to or not, it still holds true, and it's positive, then this is what I refer to as greater than. So think of great or inequality. So it's going to be an or inequality, and your inequalities would be the original, which is, if you look at it, here, A less than B, so that's the first one. Here, A greater than B is the first one, or A, flip it now, is less than the negative B. Those are your two cases, and it's an or inequality. So hopefully once we start doing the examples, it's going to make a little bit more sense. Let's look at this one. Okay, so we're looking at this, and we see it's less than, and it's a positive. So case one is going to be the given statement, which is that 3p minus 12 is less than 9. And then the other one, because it's an and, less than, the next one is going to be flip the symbol and make it negative. So now it's 3p minus 12 is greater than the negative 9. And then you solve each one separately. Add 12, you get 3p is less than 21. You divide by 3, and you get that p is less than 7, and it's an and inequality. Add 12. 3p is greater than 3. Divide by 3, not by p. P is greater than 1. So the solution, remembering set builder notation, is that all the values of p such that, now let's look at this. P is less than 7 and p is greater than 1. If we wanted to graph it, we would go greater than 1, goes this way, open circle. Less than 7, open circle, goes this way. Notice it's shading in between because it's an and inequality, and so there is an intersection. So this means that if you think rationally, the values that would make this true would make the number p between 1 and 7. And remember that we always use the less than symbols for an and inequality. And if you get confused, go back to your original. P is less than 7, p less than 7, p greater than 1. So if you reversed it, it would say 1 less than p, 1 less than p. Okay, let's look at the next inequality, absolute value. All right. Again, as I look at this, I understand and I notice that it's also, once more, an and inequality because it's less than. So I see that, once more, I have to refer back to my steps. First, we have to isolate the absolute value part. It's not isolated yet, so the very first thing I'm going to have to do before I before I continue, is to isolate. Then I get the absolute value of x is less than 9. Less than, so I know it's an and. Case 1 is the given. Case 2 is the greater of the negative. It's an and inequality. It's already been solved because the absolute value of the variable was the only thing you were looking for. There was no expression within the variable, within the absolute value. And if I was to graph it, I would go to 9, open circle, and negative 9. So let's 3, 4, 5, 6, 7, 8, 9, negative 9. And it's an and, so it shades in between. And the solution set would be the absolute value, the values of x such that x is between negative 9 and 9. Use your less than inequality symbol, and that's your answer. Okay. Next one. Absolute value. Is it isolated? Yes. Is it positive? Is positive. Now, off to absolute value inequalities. It's a greater than, so it's greater. It's an or inequality. It's going to be important for you to know that it's an or inequality. Then I set up the two cases. Case 1, the given, x minus 5 is greater than 4, or case 2, x minus 5 is less than the negative. Notice that you flip the symbol and make it negative. And then you solve. Add 5, x is greater than 9, or, because it's an absolute value of inequality that's greater, add 5, x is less than 1. So the solution is the values of x such that x is greater than, let's start with a smaller number first, less than 1, or x is greater than 9. And the way to shade is just like you know. Here's 1, less than. It's an open circle because it's not or equal to. Here's 9, greater than. And again, it's an open circle because it's not or equal to. Okay? Next one. Okay, this is a little bit more complex, which is good. Step 1, isolate the absolute value. Add 3. Now you get the absolute value of x plus 2 is isolated, is greater than or equal to 10. Greater, we know it's an or inequality. So you're going to set up the given. X plus 2 is greater than or equal to 10. Keep the equal to sign because it's part of the problem, so you have to make sure that you include it. Or inside, flip the symbol, keep the or equal to, and make it negative. Solve x is greater than or equal to 8, or minus 2, x is less than or equal to negative 12. Solution, x such that, start with the smaller number first, or x is greater than or equal to 8. So negative 12, I am going to just renumber these little numbers on the number line because it's just, the number line was just standard, so it didn't have all of the things. So let's say that if this was negative 12 here, and this was 0, and this was 8, it doesn't have to be exact, guys, it's all right. It's a closed circle on negative 12, shaded to the left. Closed circle on 8, shaded to the right. It's going outward. And that is your solution for this. Okay, word problems. These are confusing, I understand, but we're going to explain them with the hopes that it's going to help you understand them. Read it first. The average depth of a diver is 4 feet. Okay, so I know, I'm picturing in my head that a diver goes down about 4 feet. With rainfall and evaporation, the depth of the river is within a 1/4 foot of the average depth. Find the range of depths of the river. Okay, so basically what this is saying is, we know that when rain falls, you're making the water fill up. When it evaporates, it's taking water out. We know the average is within a 1/4 foot. What this is saying is that if the average depth is 4, and it's average depth of the river, and I said diver. I talk about, I don't know. So the average depth of the river is 4 feet, not of the diver. So if the average depth is 4 feet, okay, that's the average. So think of it this way. On average, we know that sometimes you could be more or less than the average. The average is 4. If it rains, you're going to add 0.25 of an inch. If it evaporates, you're going to take away 0.25. So case 1 is going to be the positive. Case 2 is going to be the negative. The absolute value inequality is going to be that whatever the amount of the river is, okay, so whatever the amount is, let's call x. If you take away the average, then that quantity that's left needs to be less than or equal to 0.25. Otherwise, it's not part of the scenario. Let me explain that one more time. If I know that the average depth of the river is 4 feet, that means that whatever the river's depth is right now, if you take away the 4 feet that it should be, you need to be between 0.25 and negative 0.25 difference. That's the absolute value inequality. And the two cases would be x minus 4 is less than or equal to 0.25. It's an and. X minus 4 is greater than the negative. Add 4. X has to be less than or equal to 4.25. Add 4. And x has to be greater than or equal to 3.75. That means, if you want to picture it a little bit better, that when you have a river, if this is the river, and here's the riverbed, or the base, the depth, how deep it is, on average is 4 feet, but sometimes the rainfall is going to make it so that it accumulates an extra 0.25, so that's going to make it 4.25, and sometimes it's going to evaporate an extra 1/4 of a foot, which means that it would be less than 4 feet, which would be 3.75. Now, to write that as an absolute value inequality, again, you would, in a solution set, you would say values of x such that we know that you're between 3.75 and 4.25. That's the depth. So there's actually, if you look at it, it's kind of common sense. You don't need to go through all of this, but I wanted to make sure you understood it. If the average depth of the river is 4 feet and it's within 1/4 of a foot, that means that you're either going to be 1/4 of a foot less than 4, which is 3.75, or 1/4 of a foot more than 4, which is 4.25. So your depth is literally between 3.75 and 4.25 feet. And this originates from this absolute value inequality. So those of you guys that are always wondering, I wonder when we're going to use this in the real world, this is a scenario. If you want to know about how much something needs to be between two items, knowing that it's give or take 25 hundredths of a foot, or give or take $10, you know that you're either going to lose 10, raise 10, and you know that means that you're between two things, which means it's an absolute value. Okay. Last inequality, or last examples. Remember that the absolute value expressions are always non-negative, okay? That's part of the idea of the first 3 steps when we're trying to figure out what it is that we have to do. We have to isolate, then we see to see if it's positive, and then if it's yes, you set up the 2 cases. So what happens when it's not positive? If it's not positive, when you're solving a regular absolute value equation, we know that it's no solution. But if it is not positive for absolute value inequalities, you either get no solution or you get all real numbers. So let's talk about what's what. If the statement is a true statement, then the answer is all real numbers. If it's false, then it's no solution. For example, here, if I have the absolute value of x plus 5 is less than negative 10, we know that anything outside of the absolute value, or anything of absolute value, is always positive. So you need to ask yourself, can you have an absolute value, can your absolute value be less than a negative number? Can you have the absolute value of anything be less than a negative? Well, if you know that the absolute value of anything has to be positive, then you cannot have the absolute value be less than a negative, because it means it's even more negative. That's a false statement. That is no solution. And the way you would graph it would be like that, the null. It's not any solution. There is no graph. You don't really leave it empty, because then it looks like you didn't do the graph. The graph is just that little circle with the dot line through it, which was kind of like 0 or no solution. Okay, so going back again, you can't have the absolute value of anything be less than a negative, because if it was less than a negative, it means it's definitely more negative, which means it's not positive, and if it's not positive, it's no solution. Let's look at the next question. Similarly, you ask yourself, can I have an absolute value if I know that the absolute value is always going to be positive? Then, can you have an absolute value that is greater than a negative? And again, if you think about the fact that it's asking you, can you have an absolute value greater than a negative? Yeah, you can have the absolute value be greater than a negative. So therefore, that would make it positive. If it's greater than a negative, it's positive. And so therefore, this means that your values of x such that x is all reals. All real numbers. And the way to show that on the graph would be to shade the whole graph, because every number would make that true. So in theory, if it helps you guys to understand a little bit more, if it is, now this is a little bit of a shortcut, if your absolute value, these are the special cases, let's call that special cases. If your absolute value is less than a negative, then that's called no solution. If the absolute value is greater than a negative, that's called all real numbers. Those are the two special cases that we would consider when we are dealing with this part of the steps. Is it positive? If yes, you set up the two cases. If no, then you ask yourself, is it less than a negative? Then it's no solution. Is it greater than a negative? Then it's all real. So if we were to add our little steps into here, then we can pretty much say that in steps for solving inequality absolute values, first you isolate the absolute value, then you ask yourself, is it positive? If yes, set up the two cases, which means that you would set up equal to in the case one is the given statement, and then case two is flip symbol and negative. And then if the answer to is it positive happens to be no, then you go to your special cases, which are these. If it's no, the special cases are it's no solution if it's less than a negative, and it's all reals if it's greater than a positive. Okay, so your job now is to go ahead and do the independent practice, remembering the steps, and remembering this here, if you want to think of it this way, you've got these steps, and this here are the two possibilities of moving them or progressing them. So by that, I mean, one more time, isolate it. Is it positive? If it is, if it's less than, you set up these two cases. If it's greater, you set up these two cases. If it is not positive, then you have to ask yourself, is it less than the negative? If it is, then it's no solution. If it's greater than the negative, then it's all reals.